We have two kinds of materials, for instance, a conductor and an insulator. And these materials are, they are built by atoms. We can figure these atoms as small balls in the conductor or the insulator in the material. But we understand that an atom has a positive charge, a neutron in the nucleus, and for instance, it can also have electrons around, right? We do understand this from other kind of courses. This is an atom. It has protons, electrons, and neutrons. Now the protons are fixed, but the electrons they are able to interact. For instance, if we have an electron here, this electron can jump in a conductor, and then it can jump to another atom, and it can jump to another atom. So the electron is able to move. But in an insulator, the electron is not able to move to no other atom. It is unable to move. So in a conductor they can move, in an insulator they can't. Well, good conductors could be, for instance, some metals, while insulators could be plastics or other kind of materials, for instance, the carpet or whatever. Now later on we're going to explain why they move, but you might actually have the idea of conductor can move, electrons can move, insulator they can't. Now whenever we charge a material, if the material is, for instance, an insulator, well, if we charge it with negative, well, you might actually see all the negative charges distributed. But when we have a conductor, in a conductor, and we charge it negatively, what will happen is that the negatives will reside at the surface, because the negative signs will tend to move away from the rest. They want to repel. In the insulator, well, electrons cannot move, so they will remain like that. But in a conductor, since electrons can move, and you're charging, then these electrons will start to move towards the surface because they want to get as far as possible from the other electrons. So if we have a conductor with their negative charges, for instance, distributed in the surface, and then we put in contact another conductor, then these charges will want to jump to the next conductor because they want to spread from each other, and this is charging by contact. It could also happen with positive charges, right? But another example is charging by induction. So for instance, we have a rod. It could be a rubber rod that has negative charges, and we put this very, very close to another conductor. What will happen is that by induction, and it's very close, it's not touching, okay? The positive charges will start to attract to the negative charges in the rod, while the negative charges will start to repel. Now, what can I do in order to get rid of the negative charges? Well, I can do something that is, for instance, called ground, and I can put some contact to another surface, for instance, the surface that can be also a conductor, and then all the negative charges will start to move towards ground till ground receives all the negative charges, and then, well, in this case, all the negative charges move, and then I can get rid of the ground, and then I have these positive charges will start to distribute as well to the surface, and that's charging by induction. So I didn't touch anything. I just put some surface very close, and then I induced charge. Last but not least, then what happens if we have an insulator? Well, let's start with, for instance, rubber, right? A balloon, for instance, which it's going to be charged negatively if you rub this to your hair, right? And these negative charges, well, what happens if you put it near, or you make contact with an insulator? Well, what is going to happen, since this is an insulator? Well, atoms will start to move, rotate more than move, because they cannot move, toward the positive side. Will start to rotate towards the balloon, while the negative charges are going to remain there. So atoms are not able to move, but they can rotate. So the positive charges are going to rotate towards the negative charges of the balloon in the insulator. Since these two attract, well, that's the reason why some balloon can actually stick to an insulator. So we have discussed the nature of conductor and insulators, how you charge a material in a conductor and an insulator, charging by contact, induction, and what happens with an insulator.